Hi, welcome to the Shiko Math Practice Lab Algebra 2 lecture series. Today, we're going to start lesson 2.5, and we are still in the chapter about the linear equations here. So in this video, will be a very short video. We're going to talk about the concept about the rate of change, because this video is going to lead into one very critical part of the linear equation is the slope concept. And we're going to discuss that in our next videos here. So in this video, let's take a look. What is the rate of the changes here? Okay, so I'm going to go to the worksheets and let's take a look here, right? Okay, so let me see where is my worksheets here. So yeah, here we go. Okay, so for this ones here, we're going to talk about, let me find my, okay, yeah, okay, so find my pen here, I got it. Okay, so we talk about the rate of the changes, right? Okay, so what is the rate of the changes here? So the rate of the change is a ratio that compare how much one quantity change on average relative to the change of the other quantities. So like for examples here, our first example, the first variables here is the time, and the next variable is the how much water in liters, right? So that means that when the time changed, how much water going to change? What is the rate of the change? So when we do this kind of problem, so let's take a look here. From 6 to 13, how much we change here? We change 7, right? Then from 13 to 15, how much we change here? We change it to 2. 15 to 23, how much here is 8. And 23 to 47, how much is the change? It's 24 here, okay? Then the same way, let's take a look at the variables, the water, how much water is here. So let's take a look from here to here. How much is the change of the water? So that means you use 24706 minus 22172 here. Then we have 25 what? We have the 2534. Okay. Then from here to here, right? So it's 25430 and 24706. How much is the change here? Is 72 what? 724 here. All right. And then from the 2A326, 25430, how much is here? This is 2A. What if you minus is 2A96 here? Then the last one is from 2A326 to 7014. How much is the change here? This is A6AA, right? So it's A6AA. So based on the our definitions, right? So I find out that the change for each variable, that's the blue one and the green one. And then in here, based on so it's the ratio of that change is here, right? So that means, so the ratio, that means is 2534 divided by 7, right? So this ratios here will be what? Will be 362. Okay, so that means the ratios here. So let me give a little bit more space here, and then we can go here. So that's so the ratios here. So the first ratio will be 2534 divided by 7, right? So that's why you get a 362. Because this one, 2536, corresponding to the 7. Then the next ones here is 724. So from here to change here is change 724, but corresponding to the how much the time change is 2, right? So you divide by 2, so you will get a 362. So this is a 362. And then the next ones here is 2A96. So 2A96 corresponding to how much time change is A. So this is the 362. So wow, so I have a constant rate. Then the next ones here, it will be A6AA. So this will be A6AA corresponding to how much change here is 24. So I have a 362. Okay, so that means here I have a 362 here. Then after that, if you just average it, right? So that means in here, from the definition, if you take a look here from the definition, they say on averages, right? So what is the change? So if you average this 362, so what is the average going to be? The average going to be 362. It's because this type of the rate of change, we call this the constant rate of change here. That means this is change is consistent, is 362, 362, 362. So in the next video, when we talk about the linear equation, so the linear equation, they have what we call this, the constant rate of changes here, okay? Okay, now let's take a look at the next examples here, right? So the next examples here, so from 0 to 3, how much is the change? It's 3, right? 3 to 4, how much is the change? It's 1, right? So 4 to 7, what is the change? It's 3. And 7 to 13, how about that? Is what? Is 6, right? Okay, now let's take a look. This is the time, right? So this is so two variables. We have a time and the distance. So then let's take a look at the distance changes here. So from here to here, from 37.3 drop to the 30.2. So how much is the change? It's a negative 7.1. Right? Now from here, from the 30.2 drop to the 27.7. So how much is the drop? It's a negative 2.5. And in here, so from the 27.7 dropped to the 20.8. So how much is the drop? Negative 6.9. Then from here to here, 20.8 drop to the 7.2. How much is the drop? Negative 13.6. Okay, and after that, then we need to find the rate of the changes here, right? So in here, the same ways here, you just use whatever the value, the rate of the change of the distance and divide by times, right? So that let's take a look at what is the first one. So the first one will be the negative 7.1. So negative 7.1 corresponding to what? It's 3. So you will get a negative 2.36 and it's continuous. So it's 6 is repeat. Okay, so the next one here is a negative 2.5 and corresponding to how much is the ones, right? So it still is a negative 2.5. Now the next one is a negative 6.9. And then how many units? 3, right? So I'm getting the negative 2.3. And okay, so then this one's here. So the last one is negative 13.6 divided by 6. So this will give you what? Negative 2.26 repeat. Okay, so let's write in here. So this is negative 2.36, and then this one is negative 2.5. This is negative 2.3. And this is negative 2.26. So this example is a little bit different, right? And the first one is a constant, right? So they are changing a constant rate. And in this example, you will see they are not really the same. They are pretty close, but they are different. So you know those points, they are not really exactly on a line. They are close, right? So they are kind of hugging the line. It's kind of close, jumping around the line, but it's not exactly. So what is the rate of the change? See here? So that means I'm going to find the averages, right? So what is the average? The average, you add all this up and then divide by 4. So the average I get is a negative 2.36. Repeat here. So that means on average, the rate of the change for this table, see here, the time with the distance. That means every time when the time increase 1 unit, distance drop on average is like 2.3 or 2.36 meters here, right? So the negative sign, all right? So the negative signs here, right? So negative signs here, that means what? Decrease, right? That means every time when the time increases 1 second, the distance is going to decrease. Then the same way like this one's here, right? So we have the positive 362. That means what? That means this is decrease. This is increase here, right? Okay, so that means this is increase. So that means when every time, when the time increase 1 second and the water goes through a channel increase, right? So the change of the water in the channel, it will be 362, right, liters per second. And so when you see a negative sign, that means this is they go into the opposite directions, right? So in here, this is go to the positive direction. That means the more time, you more water. So here is more time, you less distance here. And that's it. Like I mentioned, it's a very easy lecture series. Just to start to introduce you the concept of the rate of the change, because this is to try to prepare us to go to one of the critical part of the linear equation. Will be our next video. We're going to talk about slope concept. Okay, that's it. And so it's nice to talk to you. And don't forget to go to the next video. We are going to talk about the important concept. It's the what? It's the slope concept. Okay, you have a good day, and I'm going to talk to you next. And looking forward, to see you come to watch my videos. Okay, bye.